All right, so today we're going to talk about navigating the periodic table. Looking at some of the trends the periodic table gives us, what it tells us about the elements and where they're placed. All right, so by the end of today, you should be able to identify the major groups on the periodic table, describe the nature of them, and then the properties and why those elements are arranged in the way that they are on the periodic table. So let's take a look at how the elements are organized. First, let's look at some vocabulary to get us started. Elements, we all should know this term already. Elements are the building blocks of matter. Nothing can be broken down further than an element. As we discussed, elements are the basis to everything that exists, right? Everything in the world exists of some combination of these 118 elements combined in different ways. Then we have our periods. Periods are rows on the periodic table. If you're looking at the periodic table in front of you, your periods are those horizontal rows going left to right on your periodic table. So one way I think of remembering this is, what do periods end? Periods end sentences, right? Well, which way do our sentences go? Sentences go left to right. So periods on the periodic table go left to right, just like our sentences that they end. All right, so that's just one little reminder key. Hopefully that helps you out in remembering that periods are left to right rows on the periodic table. Let's look at some other terms. Groups. Groups are our columns. All right, so the columns that go up and down vertically, those are our groups. We also know them as families. All right, so we're going to talk a little bit more about families here in a minute as we talk about how the elements on the periodic table are grouped. But our families are our vertical columns, numbers 1 through 18 on your periodic table across the top. We can also group these elements into group A and group B. All right, and we'll look at a picture here in a second. Group A are our main representative elements, so the main elements on our periodic table. And then group B is often referred to as our transition elements, because those are where our transition metals are. So here we see another illustration of the periodic table, and we're going to take a look at the different periods and groups. So over here on the left side, you will see your periods 1 through 7. All right, notice you have your lanthanides and your actinides that break out of period 6 and period 7 and continue on down at the bottom. All right, if we look, you have number 57, and then it picks up 58, 59, 60, all the way through 71, and then picks back up here at 72. And then again here you'll see in period 7, 89, 90, 91, 92, and so forth to 103, and picks back up at 104. So that is based on the elements' properties and their characteristics, how they best fit on our periodic table. So switching gears and looking at our groups or families, those go up and down. All right, so if you'll notice, we have 18 total groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Those are our 18 groups or periods. So we said that they can further be broken down into groups A and groups B. So right here, I'm going to do it in green. You will see groups 1 through 8A. 1, 2, 3, 4, 5, 6, 7, 8. Those are our representative elements. We'll be dealing with those a lot this year. All right. Then in blue, I'll do our group B. It starts with the 1, right? B1, 2, and then picks back up 3, 4, 5, 6, 7. And then all 3 of these are grouped together as B8. So looking right here, we have 1B, 2B, 3B, 4B, 5B, 6B, 7B, and then 8B. All right, so the main thing that you need to focus on is your A group elements. That's what we'll be looking at a lot, but also being able to recognize where your B group elements are as well. So let's take a second to name that element. What element do we see on group 2, period 5? Well, we know that groups go what? Up and down. All right, and periods in sentences that are written left to right. So group 2, period 5. So let's go over here. Let me change my pen color. Group 2. And period 5. What do I have? Stratinium, SR, number 38. So we have element SR. Group 16, period 4. Groups go up and down, so group 16, period 4. So we're going to follow it across 16, 4, and that is SE. SE. So make sure when you're doing that, notice we didn't just go 1, 2, 3, 4 blocks down, right? We only went 3 blocks down, but that's because HE and H, all right, take up period 1, all right? So make sure you're looking over here from where your periods are labeled and following period 4 over. A lot of times people make the mistake of just counting straight down from the top of that group. All right, let's look at the next example. Next example is group 3A, period 2. Remember, this is now dealing with our A group elements. So group 3A, I've got 1A, 2A, 3A. All right, so group 3A, period 2. Following period 2 across, and I've got boron. And then lastly, group 15, period 5. So here's group 15, and I'm going down here to period 5. Let's follow it across and follow group 15 down, and I end at SB, antimony. So that is how we locate our elements on the periodic table using the groups and periods. Moving into how do we group our elements? How do we classify elements? So the first way we're going to classify elements is by element composition. What is our element made up of? So this is one of the classifications that you're going to see follow you throughout the next few units. Very important that you grasp an understanding of element composition. So elements can be metals, nonmetals, or metalloids. All right, so metals, as we should know, are good conductors of heat and electricity. All right, well, that's why wires are made out of metal. High luster and shine, most all metals are pretty shiny. Ductile and malleable. Ductile just means that you can make it into a wire. Malleable means that it can be bent and molded and shaped into different shapes and structures. All right, so there's metals and then there's non-metals. So they're poor conductors of heat and electricity. We would probably most directly think of plastics, things like that. Dull and brittle, right? Think about a rock. It's pretty dull. It's really brittle. It'll break off. Not a metal. So non-metals, poor conductors, dull and brittle. Then we have a mix between those two, all right? And that will be called metalloids. Metalloids are found on the, quote, staircase of your periodic table, and we'll take a look at that here in a second. And they have properties similar to a mix of metal and non-metal. It's kind of, they're semiconductors, so instead of being good conductors or bad conductors, they're just semiconductors. So they conduct electricity, but not great. So you will see that mix of characteristics because your metalloids are a mix between metal characteristics and non-metal characteristics. So it's got a little bit of a mix of both. All right, so let's take a look at where these are located on our periodic table. If we look here, here's your periodic table. I've nice color-coded it for you. You can do this to yours as well if you would like. Know that I will give you a blank one back for your test, but if this helps you as you are studying, you are more than welcome to color up your periodic table. So if we look here, notice that it said metalloids are along your staircase. So you should see a bold black line on your periodic table. That is your staircase. See how it looks like a little staircase? All right. So along that staircase, you will see your different metalloids: boron, silicon, uranium, arsenic, antimony, tellurium, polonium, and astatine. All right. Those are all metalloids. On the left side of that staircase, you will see all of your metals, all right? So over here, everything that I've highlighted in pink are all metals. So if you look, we can use some context clues. If you forget which side of your staircase is metals and non-metals, we can look. I've got nickel, copper, zinc, silver, mercury, iron. All of those are examples of metals. So using some context clues, if we forget, we can remember that the left side of our staircase are metals. What you'll notice up here is that hydrogen was not included. All right, hydrogen is classified over here with our non-metals that are on the right side of our periodic table. All right, hydrogen kind of breaks our rules here. Everything on the right side of your staircase is a non-metal, the only exception being hydrogen. All right, so again, we can use some context clues. Helium, all right, helium is what we fill balloons with. All right, helium is a non-metal. Neon, that's in the little glow sticks, all right? Chlorine that we put in the pool. Oxygen, okay? That should be your dead giveaway. Oxygen is on the right side of that staircase. Do we breathe in metal? No, right? We breathe oxygen, but we don't breathe metal, so that must mean oxygen in the right side of your staircase is a non-metal. So just use some context clues. If you ever forget which side is metal and non-metal, look at what exists on those two sides of your staircase. So next we're going to look at how we group elements by family. So remember we said families are their groups, all right? So families are our groups, those up and down vertical columns on your periodic table. These elements are grouped together based on chemical properties. So when we look back at our periodic table where we notice that a hydrogen is over here in group 1, yet it's a nonmetal with the right side of our staircase, that is because a hydrogen's chemical properties best fit those of the elements in group 1. And so we'll see that as we get into valence electrons and bonding and charges. We'll see a little bit more of why hydrogen fits best in group 1. But the short answer for that now is because they're grouped together in our groups based on chemical properties, and hydrogen best fits group 1. This group 1 here is the most reactive group on your periodic table, meaning that they are going to combine and form compounds and react with other elements more likely than any other of the elements on your periodic table. Most reactive, meaning they are ready to combine and form compounds. In contrast, group 18 is the least reactive group, meaning they don't really want to react with anything, right? They're happy by themselves. They don't want to combine. They don't want to react. Group 18 will typically exist on its own, all right? Does not like to react with other elements. So let's take a look at group 1. Group 1 we call alkali metals. Those are your elements: lithium, sodium, potassium, rubidium, cesium, and francium. That group 1 is your alkali metals. They react with water to form hydroxide or OH ions. They're very, very reactive. They want to donate an electron. So when we talk about atoms gaining and losing electrons, they want to get rid of an electron. They're soft, typically silver in color, and have a low boiling and melting point. So that metal is going to melt really easily. All right, malleable and sometimes soft enough to be cut with a knife. Well, think about sodium, Na. All right, that is part of table salt. So very easy to be cut with a knife. Low boiling point means it does not take much heat for that to melt down. All right, so what you need to know here is that group 1 is named alkali metals. All right, and here are our properties. Group 2, we call them alkaline earth metals. They're a little bit more metallic in character than our group 1 was, and they have 2 electrons in their valence shell, meaning they want to easily lose some extra electrons, right? So again, we'll get into that more next class and as we get into bonding, but just to give you kind of a precursor to what we're going to talk about, that second group wants to easily lose those electrons. They are the second most reactive group on the periodic table. Remember, group 1 is our most reactive, group 2 is our second most reactive. One way to remember the names of these two groups is group 1 is your alkali metals, all right? And group 2 is your alkaline earth metals. All right, group 1 has 1 word and group 2 is 2 words. So you've got your alkali, 1 word is group 1, and alkaline earth, 2 words, group 2. All right, so that's one way to help remember the 2 names of those 2 groups. Then we have groups 3 through 12. Those are our transition metals. They form alloys pretty easily, which is just a combination of metals. They have a high melting point, which means they're a metal that it takes a lot of heat in order to melt down. And they typically have more than one valence electron, which we'll talk as we get into the next lesson. But just to give you an idea as we're moving through this, what our electrons look like. All right, so form alloys easily, high melting points. We will get into more detail about valence electrons. Don't worry about that too much right now. And then we have group 17. Yes, we skipped groups 13, 14, 15, and 16. All right, those do not really have family names that we're worried about. You need to focus on groups 1A, 2A, and then 7A, 8A. All right, so group 17 is our halogens. They have 7 valence electrons in our outer shell, which means they're going to combine with a lot of different elements. All right, more detail again coming on that, but so that you have it in your notes when you're looking back. Those group 17 halogens have 7 electrons in that outer shell. They are very, very reactive, just like our group 1 that wants to get rid of 1 electron. Group 17 is very reactive because it wants to gain an electron really badly. All right, so the reactivity decreases as we move down. So fluorine is going to be your most reactive element, and then it's going to decrease in reactivity as we go towards the bottom. So the most likely to combine with other elements would be fluorine up there at the top, and then it decreases as we move down. Lastly, we have noble gases. All right, noble gases have full electron shells, as we're going to talk about in a little bit. What that means is that they do not want to combine with other elements. They have everything they want. They don't need anything from any other elements. So one thing I use to compare this and to kind of give you a reminder key about the fact that these don't combine with any other elements is this word noble. Think about a noble king. If you have a noble king, does he need anything else from anyone? Right? No, he has everything he needs. Noble kings don't feel like they need to combine or mingle with anyone within the community. They're noble. They sit up on their throne and they have everything they need. So that is the same way that these elements are going to respond right over here. They have full electron shells. They're full. They don't need anything from any other elements, and they don't want to combine with any other elements. They want to be right there by themselves on their little throne. All right, so noble gases, they are fully content. They do not need to react with other elements, all right? Full electron shells, which we'll talk about into the next unit. So when we look right here, this just gives us a visual of those families. Here's our alkali metals in group 1. Remember, one word is group 1, and then we have alkaline earth, 2 words, is in group 2. Then we see our transition metals here in the green in the middle. Think of it as they transition you from one side to the other. And then halogens here in group 17, and then our noble gases over here on the right side. Remember, they're noble. They don't want to combine or react with any other elements. All right, alkali metals are most reactive. Alkaline earth metals are second most reactive.